Welcome back to the motorBench Development Suite video series. To help you get started with your first motorBench Development Suite project, I'm going to demonstrate automatic code generation using our DSPIC33CK low voltage motor control or LVMC development board. Before we start, I'll make sure all the hardware is connected correctly. First, I'll connect the USB micro B cable between the J13 connector of the board and one of the USB ports on my PC. Next, I'll connect the phase wires of the brushless DC motor to the terminals of the J14 connector. Now for this particular example, the order that I plug in these wires will not matter because the control scheme is set up as a sensorless position estimator. So I will go ahead and make these connections. Make sure, hold that down. Okay, there we go. Then I'll plug the 24-volt power supply barrel connector into the development board's J1 connector and plug the board's power cord into an electrical outlet. To confirm there's power to the board, you should see that the LED labeled LD3 is illuminated, like so. After the hardware is set up, I'll make sure to download the Release Collateral folder from the motorBench Development Suite landing page. For reference, you can view the Setting Up motorBench Development Suite environment video for instructions on where the Download Release Collateral folder can be located on the motorBench landing page. I'll quickly go through where the folder is located. I'll type in motorBench here in the search bar on the Microchip landing page. As you can see, it shows up right there. I'll access the motorBench Development Suite landing page. And I can scroll all the way down and I can click on this Download Release Collateral button here to download that folder. For the next step, I'll start the MPLAB X integrated development environment. Once I get to the start page, I can start a new project by clicking on the new project icon. I'll make sure under categories that Microchip embedded and under projects application is selected. Since we're using the low voltage motor control board, I will select the DSPIC33CK 256 MP508 part number. Under Tools, I can select the Curiosity Starter Kit. I can go ahead and click Next. And under the XE I can select the version 3.21 compiler. I'll go ahead and click Next. So under the project name, we can select a name for our project. In this case, we'll just call it Sample. And then we can uncheck the Open MCC on Finish, and then click on the Finish button here. And then under the projects window, it's going to open up the sample project we just created with all of the associated folders. They're all going to be blank. They're not going to have any code in them at the moment. But we're going to change that. So first we're going to click on this MCC icon. And it's going to load the MCC Content Manager, which could take a few moments to do. And then we're going to select MCC Melody as the type. So it's setting up the configuration right now, which could, again, take a few moments. Okay, so once that configuration is complete, we'll click on the Device Resource tab here. We'll open up the libraries, and we'll see that we have motorBench Development Suite. We'll go ahead and double click on that. We'll open that up. So we'll see the easy setup window of the motorBench Development Suite open. And we see a message of not ready to generate, which is okay. There's a few steps that we have to complete before we're ready to generate the code. Right now, the copy that I'm using of motorBench is registered, or if you don't have the registration complete, you'll see a Register Now button down here. And so I'll provide a quick reminder on how to get that registration code. So you go to your My Microchip, you go to Registered Development Tools, you wait for that to load up. If you haven't registered the plugin, you can go ahead and do that. So I can click on this box here and I'll see the motorBench Development Suite, and I'll click Register. It'll give me a message that this plugin is already registered to this user because I've already previously done it on my machine, but you should see a message saying that the plugin is registered. And then you can go to this My Plugins tab here, and under the motorBench plugin, you'll see this registration code. You can go ahead and copy this registration code, go back into the environment, click on the Register Now button, and enter in that code. And so once you complete that step, your copy of motorBench should be registered. Okay, so now going back to the easy setup here in the configure window, you'll see that all the values are pre-populated for the system parameters. What I'll do now is I'll go here and I will select the DSPIC33CK LVMC board, because that's the board that I'm using. So that'll take a few moments to update. Okay, once that's selected, you'll see the DSPIC33CK LVMC. Next, you'll have to import the motor. So for this particular example, we're using one of the motors that we provide as part of supporting our motor control development kits, which is the 24-volt Hurst motor. So you go ahead and click on low voltage, and this will be the Hurst 300. We will go ahead and select that. Okay, once that step is complete, you'll see this Ready to Generate button. In the Advanced Techniques videos, we'll explain a little bit more about the electrical and mechanical parameters, and then also the tune and customize windows. But for this particular demonstration, we'll use the default values that have already been set. So I'll go ahead and go back to the MCC screen. I'll click on Generate, and that'll generate the code. That'll take a few moments. You can see the files starting to populate in our project. Okay, you can click on this user output window, and I'll scroll all the way down to the bottom, and I'll see that the generation is complete. And if I go back to the projects folder, under source files, I can see that all the code is now populated and automatically generated under both the header files and the source files. At this point, I'm ready to compile the software code and download it to the DSPIC. So I'm going to go ahead and click on this Make and Program Device Main Project button. And in the output window, I can see the software code starting to build. I can see the build here is successful and it's connecting to the programmer. We can see the software code is starting to flash onto the DSPIC. And you'll see this message here saying programming and verify complete. And so now I can go ahead and test the motor by pressing the switch 1 and you'll see the motor start to spin. And then I can turn this potentiometer to change the speed of the motor. Then I can also reverse the direction of the motor by pressing the switch 2. And then I can again stop the motor by pressing switch 1. So this tells me that the code generation and the download of that code was successful. Now let's walk through the X2C scope configuration and look at the graphs while the motor is spinning to view some motor control signals. To access the X2C scope on the MPLAB X IDE, you can click on Tools, and then you can go ahead and select Plugins. And then you can click on Available Plugins, and then you can go ahead and sort those, and then at the end here you should see the X2C scope. Now I already have it installed on my PC, so you're not going to see it here, but you'll be able to see the X2C scope plugin, and you'll be able to select the check mark here and the install button, and you can go ahead and install it. Once that installation is complete, I'll go ahead, click on Tools, go to the Embedded folder, and then click on the X2C scope. And at the bottom left, I now see the X2C scope configuration window come up. So I'll go ahead first and select a project, and it'll be the sample project that I just created for this demonstration. So the sample project is listed here in the window. And then under serial port, I'll select the right COM port that my development board is connected to. In this case, it'll be COM5. And I'll click this disconnect button. I'll go ahead, got an error here. So I'll make sure that before I hit the connect button, I'll go to Properties. And then when the Properties window comes up, click on Loading. And then I'll make sure to check mark the load symbols when programming or building for production. I'll click on Apply. I'll say OK. And just to make sure, I will go ahead and clean and build the project again before connecting. Go ahead and click on the disconnect button. And that one should say connected. I'll click on Data Views, and then I will open the scope view. You should see the X2C scope view come up. I will go ahead and I will turn my motor back on, and I can see it spinning. And then in the source, I will check that, and then I can select motor signals that I want to monitor. In the filter window, I'll do a quick search here. And one of the variables I can select is the motor.theta electrical. And that's a signal name that represents the electrical angle, which is the angular position of the rotor's magnetic field relative to a stationary reference point, which is the stator's alpha-beta frame, which is used in the field-oriented control algorithm. Go ahead and select that, and I can see that it comes up in the source window here. I'm also going to include the motor.omega electrical signal, so I'll select that. I can see that's the second entry here in the source window. And this represents the angular velocity of the motor. To view the motor signals with properly scaled engineering units, I will open the report.html file by clicking on the Files tab. I'll go ahead and navigate to MCC generated files, then to the motorbench folder, and then under aux files, I'll see the report.html file. I'll go ahead and right click on that and click on View, and then it shows up in my browser. I can do a quick search on angle, and I can represent the motor.theta electrical variable in degrees by copying and pasting the value for scale per count into the gain column of the X2C scope window like so. I'll just do a quick search here on angle, and it takes me down to the scale per count value that I can use to represent the value in degrees. So I'll go ahead, I'll highlight that, I'll copy that value, go back and open my scope view again, and then in the gain column, I can hit the Control V here to paste that value in there. I can go back into my browser window and then now do a search on velocity. And then the motor.omega electrical signal, I can represent that in RPMs by copying this scale per count value, going back to my screen, going back to the gain. Oh, we'll copy that over properly. And I'll go make sure that my motor is on. I can uncheck the single shot. So I need to make sure that the enable and visible boxes are checked for each of the signals that I've selected. I'll go ahead and click sample. And then I can see that the motor.theta electrical is represented between minus 180 and 180 degrees. And then the angular velocity of the motor.omega electrical signal name is represented in revolutions per minute. And if I change the speed of the motor by adjusting the potentiometer, I can see the period of the motor.theta electrical signal change, and then I can see the revolutions per minute of the motor.omega electrical signal change as well when I turn the potentiometer. To stop sampling, I will click the Abort button. Remember to always refer to the motorBench Development Suite User's Guide for specific information on setting up the development board and motor you are using. The User's Guide can be downloaded by clicking on the Download Release Collateral folder on the motorBench Development Suite webpage. Check out the next module for more information on the Microchip development boards you can use with motorBench Development Suite.